Okay, hope everyone is surviving lockdown okay and that you're all staying healthy. Nobody's got the virus. All is good here. This is going to be a video where I talk about exercise 10.11. I'll go through some of the odd numbered problems since the even numbered problems are assigned for homework. All right, the instructions are just to say whether the argument is strong or weak and to explain your reasoning. All right, I'm also going to talk about what kind of inductive argument each of these are. There's three basic kinds discussed in this chapter. There's analogy, there's enumerative, induction, and then there's inference to the best explanation. So this wasn't part of the assignment for you, but for the video, I want to cover some of this ground and I'll talk about these. All right, so number one, the bank robber accidentally left behind his checkbook, dropped his wallet with his driver's license. Both were traced to Joe Dokes, who was trying to hide $10,000 in his coat when the police arrived. The bank robber escaped with $10,000, but was also covered with red dye when the dye pack exploded. Joe Dokes was found to be covered with red dye. The obvious conclusion is that Joe robbed the bank. All right, so first, I hope we can all agree that this is a strong argument. Okay, the checkbook, driver's license, the fact that Joe Dokes had the exact same amount of money as was stolen, and the fact that he was covered in red dye. Now remember, this is inductive arguments, right? And inductive means that the premises do not make the conclusion absolutely certain. So there could be some crazy story or like some weird frame up, right? We've all seen those movies, right, where somebody innocent gets framed or walks into some kind of weird coincidence, right? So maybe someone stole Joe Dokes' checkbook and license and then went and robbed a bank. And in the meantime, Joe Dokes found $10,000 on the street and fell into a, painting that was red or something, right? So it's not absolutely certain. So the question for inductive arguments is not valid or invalid. It's strong or weak. The issue is how probable is the conclusion given the evidence or given the premises. So in this case, since it's very unlikely that all those crazy coincidental things could have happened, we would say it's a very strong conclusion. And again, strong doesn't mean definite. It just means very likely, very probable, right? So now, if we were trying to figure out what kind of inductive reasoning this is, we would rule out analogy, because analogy is a comparison, right? And there's no comparison being made here, right? Joe Dokes is not being compared to anything else, right? That leads to thinking Joe Dokes is guilty, right? So we can rule out analogy for this one. Enumerative induction is when you sort of generalize from a sample, right? You see a bunch of things that all have a certain characteristic and they do something, and then you think, oh, anything else that has that characteristic is going to do that thing too. And so it's generalization from a sample. And again, there's not... so Dokes isn't thought guilty because of generalization from a sample, right? So it's not enumerative induction, which leaves, of course, inference to the best explanation, all right? What inference to the best explanation is when you have something that needs explained and you have an idea that does explain what you need to be explained, and it does it well, and it's consistent with other things you believe, and it has all these other values that he talks about in the chapter. So we don't think Joe Dokes is guilty because he's being compared to anybody else. We don't think he's guilty because of any kind of polling or sample. We think he's guilty because his guilt is the best explanation for all of these things. For why his checkbook was at the scene, for why his wallet was there, for why he's got red dye on him, and why he has $10,000, right? So the best explanation for all the evidence is the guilt of Joe Dokes, right? So that's why we would say this is inference to the best explanation. And again, it is a very good explanation, so that's why we say it's a strong argument. Okay, number 3, it was sunny in Seattle yesterday for the first time in 4 weeks. Therefore, it will probably be sunny in Seattle all next week. All right, so again, if we think about the 3 types, analogy is comparison. There's no comparison being made here. It's not like, oh, Seattle is like London and it rains all the time in London, but it's nothing like that going on. There's no comparison. So it's not an analogy. Enumerative induction is when you generalize from a sample, and that is what seems like is going on here. Today was sunny, all right, after 4 weeks of rain. So since today was sunny, probably all next week will be sunny. So this person is making a generalization based on a sample. So this is enumerative induction. All right. Now, strong or weak, hopefully you can see that this is a very weak argument. And if you think about why it's weak, again, if you go back to the chapter, I'm going to pull it up here, and you go to the section on enumerative induction. This is page 273. You can see that there are these 3 things that are important when you're doing enumerative induction, right? So first, sample size. You should have a big sample size. The bigger, the better, right? So the bigger the group, the more likely it is, the stronger the argument. Variation. So it shouldn't just be a sample of all the same things. Like, it should be a representative sample of the group as a whole. And the more representative it is, the more likely the argument is to be strong. And randomness. The people or the things in the sample should be selected randomly. That makes the argument stronger. All right, so if we go back to number 3, it was sunny in Seattle yesterday for the first time in 4 weeks. Therefore, it will probably be sunny in Seattle all next week. We can see one reason it's weak is a very small sample size, right? The inference is based on 1 day. It's a very non-representative sample because for the previous 4 weeks, it rained. 1 day, it was sunny, right? So the sunny day is not representative, and it is random, I guess. I mean, but it just happens to be today. So it's not like you just picked a day out of at random. You just focused on today. So it's random in the sense that it's just any day, but why pick today, right? So for all these reasons, it's weak, right? It's only 1 day, so it's a very small sample size. It's not representative of Seattle weather in general, at least if we look at the last 4 weeks. And you just picked it. Why? Because it was today, or because it was sunny and you like it to be sunny, or what? So for all those reasons, it's a very weak argument. All right, now number 5 says few cats are orange colored. I hear a cat meowing across the street. The cat meowing is probably not orange. Now, again, if we think about the different kinds, we got analogy. There's not an analogy being made here. It's not comparing this cat to some other cat. Is it enumerative induction where you're generalizing from a sample? Pretty much, right? You're saying you hear the cat meowing across the street, so it's probably not orange. So it's enumerative induction, generalizing from a sample. Okay, so now the question is it a strong argument or a weak argument? Okay, so the sample size is Well, what is the sample size here? I mean, we are talking about just one cat, the one that's meowing across the street, but we're talking about it in relation to the class of all cats, right? So that's a big sample size in that sense. So sample size all cats is big. And the cat meowing across the street is certainly random. I mean, you're just picking the random cat that's meowing across the street. But there's only one cat that you're picking, right? So in a way, this looks like a very weak argument because it looks like you're generalizing from one case, right? The cat across the street. But in a sense, it's a strong argument because of the first premise that says few cats are orange colored. So it kind of depends on what we mean by few, right? So think about other kind of similar arguments that you might make, right? So imagine that few people in the world are colorblind. You know, I don't know the percentage, but say it's something like, I don't know, 5%. I don't know if that's good or close or not, but say hypothetically 5% of people are colorblind. And you look out the window and you just see some random person walking by the window. If you concluded he or she's probably not, not colorblind, is that a strong argument or a weak argument, right? Well, it's strong in the following sense that there's a 95% chance that you're correct. And that's pretty good odds, right? So if there's 95% of people are not colorblind, then there's a pretty good chance that any random person in the population that you pick is not going to be colorblind. Now that could change, right? Like if there's an ophthalmologist who specializes in treating colorblindness or something right up the road from you, then that's going to change things, right? But that's not part of the premises, right? So few is not a very well-defined term here, but it definitely means less than half, and it usually, if you say few, it means a relatively small percent, right? So I think depending on what you mean by few, this could be considered a strong argument, right? If few means what it does typically, which is, a small percent, right? So if a small percent of cats are orange, then any random cat you choose is not very likely to be orange. So 5 is strong, or at least I'd say not weak, because of that word, few. All right. So that brings us number 7. Planets have been discovered orbiting many stars. The stars found with orbiting planets all have in common 6 characteristics. No star lacking planets have been found to have all 6. A new star has been discovered. It has all 6. It is probable that the new star has planets. So again, this is not analogy. It's not comparing this star to other stars. Well, I guess in a sense it is, right? It's comparing this star to other stars with these 6 characteristics. So I guess you could argue this is analogy because we are comparing and we're saying that because these other stars have this property and this star is like them in relevant ways, then this star will have that property too. So you could argue this is analogy. You could make a case for enumerative induction too, because you're saying, you're generalizing from stars with these 6 characteristics to all stars with these characteristics. And even inference to the best explanation is not a bad diagnosis here. But I think it would be better diagnosed as inference to the best explanation if this was a theory about stars. All right, now by the time on this video, I'll finish